Okay, we're here with Rita to talk about solving multi-step equations. So we're going to be taking many steps to solve these with rational coefficients. Ready to go?
Yeah.
Okay, so before we do some starter examples, let's just remind ourselves what a coefficient is and what rational means, okay?
Okay.
So a coefficient is the number that multiplies by a variable, okay? So for instance, in the term 5x, 5 is the coefficient of x. Make sense?
Yeah.
Okay, now, a rational number is one that can be represented by a ratio, okay? So a lot of times people think of rational numbers as fractions because a ratio and a fraction are pretty much the same thing. So 2/3 is a fraction. It's also a ratio, so it's a rational number. But 5 is also a fraction because it's 5/1, right? So even an integer like 5 is a rational number. And both positive and negative numbers are rational. So if you have -5 or -2/3, those are also rational numbers. Today, what we're going to be really focusing on is those fractions, though, okay? Because when you get fractions into an equation, you want to get used to getting the variable by itself, solving for that variable, even though you're dealing with fractions, okay?
Okay.
Okay, good. So let's look at an example. We have here a starter example with -1/7 y equals 3, okay? Now, we want to get y by itself, right? So what's bugging us?
The -1/7.
Good. And there's a couple things about that -1/7 that are kind of tricky to deal with. One is it's a fraction, and the other is it's negative, okay? So let's first talk about the fraction part. 1/7 times y is kind of like y over 7, right? It's the same thing.
Right.
And in that case, the 7 is doing what to the y?
Dividing.
It's dividing. So to get rid of it, we'll want to multiply by what?
7.
7, okay? So if we did that, we multiplied both sides by 7, it would get rid of the 1/7, but it wouldn't get rid of what?
Negative.
The negative, right? So how can we get rid of that negative also at the same time? Any ideas?
Multiply by -7.
Good. And so let's do that and see what it ends up being. So here what we have is the 7 and the 7 are going to cancel. And then this negative times this negative is a negative times a negative would be a positive. All you'll be left with is that 1, so you'll have 1y. And that's what we're looking for. And what will we have on the right-hand side?
-21.
Good. So that's our answer, y equals -21. So by doing just one step there, multiplying by -7, we were able to get rid of that fraction and the fact that it's negative. Okay? All right, so now let's take a look at a little bit of a harder example. 3/5 x equals -2. Okay? Now there are a couple ways to solve this. I'm going to show you one way that I like first, but then I'll tell you about an even faster way if you like that kind of way. Okay, so there's the way that I like to think about it is that fraction is a numerator that's multiplying by our variable and a denominator that's dividing into our variable. Okay, and so I like to get rid of that denominator first. And just like with the 7 up here in our first example, we multiplied by 7 in order to get rid of it. So here we can multiply by what to get rid of that 5?
5.
Yep, and we don't need to do any negatives here, right? Because it's just a positive coefficient. Okay, so let's multiply both sides by 5. And what's going to happen on the left-hand side?
The 5s will cancel out, so
Yeah.
you get 3x.
Good, and how about on the right side?
You'll have -10.
Okay, so let's go ahead and write that. 3x equals -10. Now we've taken care of the denominator, and now we can focus on that numerator, which is now just a coefficient of x. It's an integer 3 multiplying by x. And how do we get rid of that?
Divide by 3.
Okay, good. So let's go ahead and do that. So what will be on the left-hand side?
X.
X. And on the right-hand side, we usually get that negative out of the numerator and just put it out in front of the fraction. So what will that be?
A -10/3.
Good. So we can say x equals -10/3, and that's our answer. So we'll go ahead and circle that. Now, just so you know, some people like to do this in one step, where they say, okay, well, the 3 is multiplying by the x, the 5 is dividing. Let's multiply the whole thing by 5/3, the reciprocal of 3/5. That'll get rid of the 5s and the 3s all in one step. And if you imagine -2 times 5/3 would be -10/3. So for some people, that's easier for them, and I think that's a great way to go too. I just like to go ahead and take it step by step. Okay, let's look at a harder example now. Here we've got something that looks pretty hairy. 2/3 times a quantity, x minus 7, equals -3/2 times a quantity, x plus 4. So not only do we have positive and negative, we got some multiplication by some quantities. And the really tough thing here is that we have two fractions and they have different denominators. There's a 3 in the denominator here and a 2 in the denominator here. So unlike these problems over here where it was easy to figure out what to multiply by to get rid of the denominator, here it's a little bit harder. We can't just multiply by 3 because that wouldn't get rid of the 2, and we can't just multiply by 2 because that wouldn't get rid of the 3. So we need some number here that we can multiply by both sides that will get rid of the 3 and the 2. And this is where you can reach back to your earlier math and think about least common multiple. Any number that both 3 and 2 divide into would work, and the easiest one to use would be the least common multiple, which in this case is 6. Okay, so follow my logic here. Well, let's go ahead and multiply both sides by 6 to see what happens. And I put it in a different color here so you can see it more easily. On the left-hand side, we're going to have the 6 and the 3 are going to kind of interact in a way. They're not going to just cancel, but 6 divided by 3 is what?
2.
2. So on the left side, we'll have 2 times 2, or 4 times this quantity. And then over here, the 6 and this 2, they're not just going to cancel either, but what's 6 divided by 2?
3.
3, and 3 times negative 3 is?
Negative 9.
Negative 9. So we'll have 4 times this quantity and negative 9 times this quantity. And let's go ahead and write that out. Okay, and the reason we were able to get to this, what I think is a much simpler here than what we had up here, is because we use that least common multiple as the thing to multiply by. Okay? Now, a next step here, we could go a number of different ways, but we don't really want to divide by 4 or negative 9 because that'll get us right back in fraction land. So any ideas what to do next?
You could distribute the 4 and the 9.
Good, so let's go ahead and do that. So the left-hand side becomes 4x minus 28, and the right-hand side becomes negative 9x minus 36. Now at this point, you probably want to get both the variables all onto one side, yeah?
Yeah.
What would you do to do that?
Let's see, you could get all the variables on, you could add 9x.
Yeah, can add 9x. And so what will we have on the left side?
13x minus 28.
And on the right side?
Negative 36.
Very good. And good job remembering the negative that's there in the 36, because that negative 9x was minusing 36. So let's go ahead and write there. Okay, now we've got the 13's bugging me and the negative 28 or minus 28 is bugging me. What do you want to do next?
Add 28 to both sides.
Good. Okay, so let's do that. On the left-hand side, we'll have what then?
13x.
Good. And on the right-hand side, what will we have?
Negative 8.
Good. Good mental math there. Now what's the last step you'll take?
Divide by 13.
Divide by 13. Okay, so when we do that, what will the left side be?
X.
And then the right side will be?
Negative 8/13.
Very good. Okay, so that's our answer. And the important thing that we want to remember here is that we are practicing some different skills. One is to figure out how to get rid of fractions so that we can solve the rest of the equation in the kind of easier fashion. And so sometimes that means just multiplying by one fraction or a reciprocal, and sometimes that means multiplying by the least common multiple when you have fractions with different denominators. Make sense?
Yeah.
Okay, good. Great job.